massive ash plumes from an Ethiopian volcano.
After 12,000 years of silence, a mighty Ethiopian volcano has roared back to life, sending ash high.
The Hayli Gubbi Volcano has sent smoke and ash 14 kilometers high this Sunday, its first eruption in recorded history.
You walk into an airport in East Africa expecting a normal day of travel, but the departure board is a wall of red: cancelled, delayed, rerouted. There is no massive storm outside, no obvious security crisis. The culprit is a volcano most people had never even heard of, sitting in a remote corner of northern Ethiopia. On November 23, 2025, Hayli Gubbi, a usually quiet shield volcano in Ethiopia's Afar region, suddenly blasted a huge column of ash and gas into the sky. The plume shot to around 14 kilometers, about 45,000 feet, straight into the cruising altitudes of long-haul jets. Within hours, that ash cloud blew across the Red Sea toward Yemen and Oman, then onward along busy air routes that connect East Africa, the Middle East, India, and even parts of China. So the big question in this story is simple and dramatic. How did one eruption in remote Ethiopia end up grounding and rerouting flights across East Africa and much of the Eastern Hemisphere, and what happens if it wakes up again? The answer stretches from ancient geology to modern jets, and it starts with a volcano that may not have erupted in more than 10,000 years. First, where is this thing? Hayli Gubbi is a shield volcano in Ethiopia's Afar region, in the northern part of the country. It sits roughly 800 kilometers northeast of Addis Ababa, in the Erta volcanic range, which is part of the East African Rift System. This is a place where the African continent is literally being pulled apart over millions of years. Geologists knew Hayli Gubbi existed, but for a long time it was considered long dormant. There were no recorded eruptions in human history, mainly because the region is extremely remote and has been understudied. On most maps, it was just another name in a long list of quiet volcanoes. That status changed in a matter of hours. On the morning of November 23rd, around 8:30 in the morning UTC, satellite systems that track volcanic ash suddenly picked up a towering plume rising from Hayli Gubbi. Local people in nearby Afar villages said it sounded like a sudden bomb, followed by shockwaves and a huge grey cloud rising into the sky. The eruption threw ash and volcanic gas up to about 14 kilometers into the atmosphere. Ash and sulfur dioxide streamed over the Red Sea and into Yemen and Oman, later reaching parts of Pakistan, northern India, and moving toward China. On the ground in Ethiopia, ash fell over villages like Afar, Fia, and Gubbi, coating homes, grazing land, and water sources in fine grey dust. The most explosive phase lasted only a few hours before calming down. But the ash that reached jet cruising altitudes did not disappear just because the volcano quieted. It drifted into the highways of the sky, and that is where the story flips from a local eruption to a global problem. Here is the wild part. Volcanic ash is not like fluffy campfire smoke. It is more like flying a jet through a cloud of microscopic glass and rock. Volcanic ash is made of hard, abrasive particles that can sandblast cockpit windows, sensors, and the leading edges of wings. Inside jet engines, glassy ash particles can melt at high temperatures, then re-solidify on turbine blades and in tiny cooling holes. That buildup can block airflow, disrupt fuel burning, and cause engine surges, or even temporary flameouts. In the past, airliners flying through thick ash plumes have experienced multiple engine failures and severe damage. Those close calls changed aviation forever. Today, global aviation agencies and engine makers treat volcanic ash as a serious no-go zone. International monitoring centers track ash in real time using satellites, weather models, and pilot reports, then issue warnings so aircraft can route around dangerous areas. So when Hayli Gubbi hurled ash into cruising altitudes, it did two things at once. It contaminated some of the busiest east-west air corridors in the world, including routes linking East Africa and the Middle East to India and beyond. And it forced airlines and regulators to make hard choices very quickly. Either reroute, delay, or ground flights rather than risk jets flying through invisible glass dust. To make things harder, pilots often cannot see ash on onboard weather radar. From far away, an ash cloud can look like an ordinary cloud, especially at night. That is why satellite-based advisories and strict volcanic ash procedures exist in the first place. Once the ash plume spread out, the impact on aviation came fast. Tracking data and airline statements show that the eruption disrupted air traffic across parts of Africa and Asia, especially along high-altitude corridors that many East African routes rely on to connect with the Gulf and South Asia. Flights that were perfectly safe on paper the day before suddenly crossed through zones marked as hazardous. In the days immediately after November 23rd, Air India cancelled multiple flights so that planes that might have flown near ash affected zones could be inspected, and so that crews could avoid specific high-altitude corridors flagged by regulators. Another Indian carrier, Akasa Air, suspended services to cities like Jeddah, Kuwait, and Abu Dhabi on November 24th and November 25th, because ash in the region made those Gulf corridors unsafe. Other airlines, including regional and international carriers, cancelled or rerouted flights connecting India, the Middle East, Africa, and beyond. Some flights took longer, looping around the worst of the ash. Others were simply scrubbed from the schedule. Many of these flights either cross or connect through East African and Red Sea airspace. When key segments are suddenly off limits, schedules across the wider East African region tighten. Some departures are held on the ground until safe alternate routes and altitudes can be confirmed. At the same time, aviation authorities issued detailed advisories. They told airlines to avoid ash-contaminated airspace, review flight plans and manuals, and report any suspected ash encounters, including unusual smells, engine anomalies, or smoky haze in the cabin. For passengers, all of this shows up as one brutal message on a phone or a screen. Your flight is delayed. Your flight is cancelled. Behind the scenes, it is a huge real-time puzzle. Hundreds of planes, thousands of people, and one moving cloud of microscopic glass. While the world focused on flight maps, families in Afar were watching their world turn grey on the ground. Reports from local officials describe villages blanketed in ash, with grazing shrubs and dry grass coated in dust. Livestock struggled to find clean feed and water. Residents coughed, dealt with eye and throat irritation, and worried about what would happen if the ash polluted wells and ponds. Mobile medical teams from the region were sent in to treat respiratory issues and assess water contamination risks. Masks and basic supplies suddenly became important tools, not for a virus this time, but for a volcano. The economic stakes are huge at the local level. Many households in this part of northern Ethiopia depend heavily on herding goats, camels, and cattle. A layer of ash over grass and water points can turn a short eruption into a long-term livelihood crisis, even if no one is injured by lava or immediate fallout. So while international headlines talk about cancelled flights, people living closest to Hayli Gubbi are worried about food, water, and their herds. Those effects can last long after the ash stops falling from the sky. Now comes the question that sounds like a twist from a movie. Why now, after so long? Scientists think Hayli Gubbi has not erupted in at least 10,000 to 12,000 years, based on volcanic records and the lack of any known historical eruptions. For all of recorded human history, this volcano has been quiet. So what suddenly changed in 2025? The short answer is that the African crust has been slowly tearing apart under this region the entire time. Hayli Gubbi sits in the Afar Rift, where the African, Arabian, and Somali tectonic plates are pulling away from each other. This stretching thins the crust, lets magma rise toward the surface, and feeds a chain of volcanoes, including the better-known Erta Ale. Hayli Gubbi is a shield volcano, built from many flows of runny basaltic lava over long timescales. Satellite images show relatively young lava flows around the volcano, suggesting it may have had unrecorded eruptions in the last few hundred years, far from large towns and before modern instruments could catch them. In other words, it may have been more active than people realized. The 2025 event was clearly explosive, with a strong gas and ash component, not just a gentle lava ooze. That tells scientists that there was plenty of gas-rich magma waiting at shallow depth, ready to fragment and blast upward once the pressure conditions were right. Here is what scientists are not claiming. They cannot yet say that this marks the start of a long new eruptive era for Hayli Gubbi. They also cannot precisely predict when, or if, this volcano will erupt again. Volcanology can estimate probabilities based on gas output, ground deformation, and earthquake activity, but it is not a perfect crystal ball. The honest version is that this eruption fits what geologists expect in a highly active rift zone, but it still surprised them because this specific volcano had never made a move in all of recorded human history. That mix of expected behavior and sudden surprise is exactly why aviation planners, disaster managers, and local communities are now treating Hayli Gubbi as a serious new neighbor. The good news is that the explosive phase of the eruption has subsided. Ash at cruising altitudes has mostly dispersed or moved eastward toward the Arabian Sea and beyond. As the plume thinned and spread out, high-level hazards decreased. Meteorological agencies reported that ash above about 10 or 11 kilometers faded from most satellite images within a couple of days. Remaining lower-level ash and gas continued drifting east, becoming weaker as it spread. Air traffic along affected routes gradually returned closer to normal patterns once ash concentrations dropped below safety thresholds. But this is not a story that ends the moment the plume fades on a satellite map. There are several big things to watch next. Local recovery in Afar will depend on how fast communities can clean water sources, protect livestock, and restore grazing land. Follow-up assessments by regional authorities and aid groups will determine whether longer-term help is needed. Scientific monitoring will likely increase. Expect more field campaigns and satellite studies, mapping new lava, measuring gas output, and refining models for the Afar rift. Hayli Gubbi has jumped to the top of many research lists. Aviation procedures will also be reviewed. Agencies in Africa, the Middle East, and South Asia will look at how this event was handled. Were advisories fast enough? Were reroutes efficient? What did engine checks reveal? The answers will shape future volcanic ash playbooks. This eruption is a powerful reminder that volcanic ash threats are not just a problem for Europe when Iceland erupts. A single volcano in East Africa just demonstrated how tightly connected our skyways really are, from Addis Ababa to Dubai to Delhi and beyond. In the end, Hayli Gubbi's surprise eruption is really two stories in one. On the ground, it is about remote communities in Ethiopia's Afar region waking up to ash-covered homes, thirsty animals, and visiting medical teams. In the air, it is about invisible hazards at 35,000 feet, forcing airlines to ground or reroute flights across East Africa, the Middle East, and South Asia because flying a jet through volcanic glass dust is simply not worth the risk. The deeper lesson is that Earth's slowest processes, like continents pulling apart, can suddenly collide with our fastest systems, like global aviation. A volcano that slept through all of recorded history woke up for a day, and the whole region had to adjust. No one knows exactly when Hayli Gubbi will speak again. But now it is no longer an anonymous hill in the desert. It is on the maps of pilots, planners, scientists, and the people who live in its shadow, watching the restless edge of our planet.